Welcome, learners, to this revision session in which we are going to revise a physics paper which is written by our students, Blackslides online tuition. Alright, this was supposed to be end of holiday examinations. Okay, so this paper was written by our online students in 2023. Okay, and this is physics paper 1, which contains 13 questions split into two sections, section A and section B. All right, the paper takes the structure of the Msce paper, Msce exam. Yeah, so it's a complete paper to be written in 2 hours, just like the Msce paper. All right. So we are going to go through this paper together. This was written by our online students in 2023. So we are way advanced in years. We've come from far, as you can see. All right. So without further ado, we're going to start answering question by question as we do all the time. Question number 1 is saying define the term work done. We define work done as simply the product. Work done is the product of force and the distance in the direction of the force. In the direction of force. That's the formal definition of work done. Define work done. So when the examiner says define work, it means you should put it in words. I've seen some candidates who simply write the equation for work done as W equals to FG. No, you lose marks. You lose marks if you simply write the equation for finding work done. You have to put it in a sentence form. Put it in a sentence form. Define the term work done. So we are saying work done is simply the product of force and the distance in the direction of the force. In this case, the force is the applied force. Yeah, the applied force. All right. Question number 2, sorry, B, part B. Okay. Part B, 1B, we are told in the first place that a crane lifts a load of 2,000 kgs through a vertical distance of 3 meters in 6 seconds. Determine the work done. All right, so here we have a crane. In the first place, we have a load of mass 2000 kgs. 2000 kgs being lifted. This is being lifted through a height of 3 meters. Okay. Okay, so this height is 3 meters. This is this one here. That's the height of 3 meters. Determine the work done. So when work is being done through a height, such work is said to be done against gravity. So this is work being done against gravity. So work done against gravity is found by using the equation work is equal to mgh. Mass times acceleration due to gravity times height. So we are told here that the height is 3. The height is 3 and the mass is 2000 kgs. And in practical situations, G is taken to be 10. G is taken to be 10 newtons per kilogram. Yeah, so 10 newtons per kg. So in this case, therefore, all we have to do is substitute. So we have mass is 2000 kgs. G is 10 newtons per kg multiplied by 3 meters. Alright, so the kgs are going to cancel out, so that effectively our work done is going to be 2000 times 10 is 20,000, then multiplied by 3. Alright, so multiplying this shall give us 60,000. This must be 60,000. That means the work done is 60,000 joules. That's a lot of work done by the crane. But we always like to say that values that are too large must be expressed in standard form, standard notation. So we have 6 multiplied by 10 to the power 5 joules. So that's the amount of work done by the crane. You can go through the solution again. Go through the solution and convince yourself. You can also try to work it out on your own just to confirm. Yeah. Part C. State the law of conservation of mechanical energy. The law of conservation of mechanical energy states that energy is neither created nor destroyed, but changes from one form to another. Or energy cannot be created or destroyed, but changes from one form to another. Yes, that's the law of conservation of energy. So we are saying energy is neither created nor destroyed, but changes. But changes from one form to another. That's called the law of conservation of energy. You can try to put it in a way that is convenient to you, all right? As long as you don't change its meaning. It has different versions. In some cases, we say that the total energy of the universe is constant. It is still okay to say like that. The total energy of the universe is constant, meaning that energy cannot be destroyed and it cannot be created, but it is possible to change it from one form to another. For example, kinetic energy, which is the energy due to the motion of a body, can change to potential energy, which is energy due to position of the body with respect to the earth. All right, so that's what we have. So far, so good. If you have just joined this channel for the first time today, consider subscribing to the channel so that you don't miss on anything that we bring in the future. And also, if you need a one-on-one tutoring, you are free to contact us on the number that we always share so that you're going to be assisted accordingly. All right. Number, okay, part C2, C Roman numeral 2, state two types of mechanical potential energy. All right, remember we have two types of mechanical energy, namely we have potential energy and the kinetic energy. Don't forget that. So we are saying energy is divided into two. All right, no. This isn't right. Potential energy, mechanical energy, can be divided into two categories, namely kinetic energy, which is the energy of a body due to its motion, and it can also be another class or component of mechanical energy is the potential energy, mechanical potential energy. And the potential energy can further be, potential energy can also be split into gravitational potential energy, and the elastic potential energy. elastic potential energy. Elastic potential energy. It's also known as strain energy. All right, so the question here is asking us for mechanical potential energy, two types. Yeah, so what we need now to state here, it means obviously we are going to exclude the kinetic energy component of mechanical energy. Therefore, the answers to the question would be gravitational potential energy, and the elastic potential energy. Elastic potential energy and gravitational potential energy. You can also call elastic energy, you can call it strain energy. This is energy of a body which is under stress or strain. For example, a spring, when you stretch a spring or compress a spring, you are basically giving it strain energy or elastic potential energy. All right, D, a bulb of mass 100 grams is suspended using a 1.5 meter spring, okay, primary support, and it swings through a vertical height of 50 centimeters as shown. Alright, so that's what we have. Now this is not supposed to be a spring, it's supposed to be a string. Yeah, so that's a string. Okay, so a mass is attached to it so that it can swing this way. You can also swing this way. Okay, and then we are asked to determine the potential energy at the position A. So potential energy, once again, is equal to mgh, for which the mass, we are told the mass is 100 grams. In kilograms, that's 0.1. So it means we have 0.1 kgs. 0.1 because we are converting the 100 grams to kilograms by dividing by 1000. Yeah, which is 0.1. So you multiply this by 10, 10 kilograms per newton, and then multiply this by the height. We are told the height is 50 centimeters. So 50 centimeters must be changed to meters, which is 0.5. Yeah. So multiply this by 0.5. Alright, so multiplying this by 0.5, check your mathematics Here we are looking at the 0.1 multiplied by 10 and multiplied by 0.5, which is also 0.5, presumably. So the answer should be 0.5 joules. Remember, the units of work done is the joule, because work done is the same as energy transfer. Calculate the velocity of which the bulb passes through point B. Alright, so this mass is oscillating between from point B to A and back through B. So here we need to apply the law of conservation of energy. So at A, it has potential energy, which is mgh, while at B, it has kinetic energy. The potential energy is going to change to kinetic energy with the value half mv squared. Yeah. So here what is happening is that mgh is now becoming half mv squared, or potential energy is changing to kinetic energy. That's what is happening, and that's exactly what you're going to apply here in order to solve for velocity. So potential energy is changing to half mv squared. Half mv squared is the formula for calculating kinetic energy. And we just calculated half mv squared. We just calculated potential energy, which is which is 0.5. So we have 0.5 being equal to half mv squared. Remember, the mass is 0.1 kilograms, and then we have v squared. Alright, so in this case, we need to make v squared the formula, the subject of the formula. So v squared is equal to 0.5 times 2 divided by 0.1. That's making v squared the formula. Alright, so using whether you use a calculator or otherwise, of course, 0.5 times 2 is 1. Then you divide by 0.1. This must give us 10. Yeah, 1 divided by 0.1 is 10. Yes, it's 10. Alright, so this is v squared is equal to 10. That means v is equal to square root of 10. So the velocity therefore is going to be square root of 10. Square root of 10 is the 3.2 or 3.16. Don't forget meters per second, the units. Okay, so that's it for now. I would like to leave you now this time. Remember, we were looking at a paper which was written by our online students, Blackslides Online Tuition. Originally, this school, online school, was referred to as just a tuition provider, but with time, it grew into a secondary school. It graduated into a secondary school, which is called the Blackslides Online Secondary School. Yes, you can request this paper so that you can also you can complete the rest of the questions and go through the rest of the questions. It's a very good paper according to me. If you can have this paper and practice, I'm sure it's going to help you a big deal. Okay, I must leave you now. Consider subscribing to the channel if you have not already done so. If you have already subscribed, you may also wish to get to enroll into our online class. It is going to be pleasant to have you there. For now, bye-bye. My name is Mr. Pochilola once again. Bye.